Why do we use foam to create waterfalls? I'm going to show you how, but first,
Make sure you turn your volume on ASMR video.
all right, I want to talk about a few details here that are actually often overlooked. And in my opinion, this is really important because it actually gets the water to go to where we need it to. So we do all this beautiful rock work. We work with rubber membranes. We're not working with mortar. We're not working with concrete or anything like that. So what we need to do is seal the joints in between the actual stones. What we want to try to do is force the water to go over the rock versus underneath everything. Otherwise, when you turn on your waterfall, it's actually going to look awful. It's going to look like a bunch of wet rocks. You're not going to see actually water flow. We want to see water going over the top of the rocks, creating that whitewater action, which is going to give the sight and sound that we're always looking for. This particular waterfall, fairly simple. We have three main stones that we use. We call these our frame rocks. The other thing that we're doing is we're taking into consideration the major viewing areas. We turned this waterfall a little bit to get it visible from the deck area. So now what I want to try to do is I'm going to show you these little inside tips and tricks and secrets using waterfall foam. I like to call this Pond Builder's duct tape. We use it for everything, all types of applications, super versatile. It's a polyurethane foam. It actually has carbon black added to it, so it's going to be more UV stabilized. But that polyurethane, this is a low density or low expansion formula. This material is used in insulation around the world. Fills up big voids and cavities and gaps and things like that for insulation purposes. It's not what we're looking for on our project. We're looking for minimal expansion, which gives us a higher density. So it's going to be more dense material, which is going to give us a little bit of that structural rigidity that we're looking for. So look at the size of this gap. There's no way water would ever get over this rock. So by using our polyurethane foam, I'm going to seal this, but I'm going to actually show you another little trick that I like to use. So I'm going to take this, I have a bed of gravel, which is going to give me the structural rigidity on the bottom. I'm going to take the foam and I'm just going to start laying down a bead. Now that I have a nice bed of that foam in place, I'm going to take a piece of our medium duty geotextile material. Very tough, very durable, will hold actually thousands of pounds. This has a fibrous material to it, so it's almost three-dimensional. I'm going to embed it into the foam. It's like adding rebar to concrete. It's going to increase the load-bearing capacity of the foam itself. So I've already pre-cut this. This is going to lay it in place. And then what I'm going to do is I'm going to take river rock, pour it right over the top. What that's going to do, I said this material expands. If you've ever used it before, it puffs up. What I want it to do though, instead of puffing up, I want it to go downward. I want it to bind into the river rock more. So now once I get it roughly in place, you can feel it. Come in with my river stone. That's going to keep that weight on it, and it's going to force the foam to go into all the little nooks and crannies and crevices, which is exactly what you need because water is going to find the weak point. It will find the path of least resistance every single time, and it will get around everything. So now this is going to fill up with water, but it's not going to penetrate through that layer of foam. What I have to keep doing, work my way all the way along this entire edge to ensure that all the water goes over this stone. Now you may periodically, this stuff does cure relatively quickly, so you're gonna have to kind of keep that little tip cleaned off, otherwise it gets gummed up, doesn't go where you want it to. You're gonna have to shake it as well, so it will settle out. There we go. The other thing I have to do is, you see this piece of fabric, water's going to want to get underneath that. So sometimes there will be one continuous piece. If there's one continuous piece, you don't have to worry about it. But because this is an open end, I want to put foam under here to keep it from going in between everything. Oof. All right, for waterfall construction techniques, there's a couple things that we have to take into consideration. One is the type of stone we're working with. In this application, these are Wisconsin granite. Relatively smooth rock, but you do get broken pieces like this. I'm gonna choose these for my waterfalls because it's gonna give me a better opportunity to create a wider waterfall. The other thing we have to take into consideration is the flow rate. That's a function of the size of the pump as well as the size of the piping. The bigger the diameter of the pipe, the bigger the horsepower on the pump. Once you take into your calculation total dynamic head, that's going to tell you how much flow you're going to get. Now for a waterfall like this, I'm shooting for about 2,000 to 3,000 gallons per hour per foot of waterfall width. That's going to give me the desired effect. Talking about the type of rock, I mentioned the broken characteristics. A rock like this will create a nice waterfall because it has a clean fractured edge, but also it has kind of a negative face on it. So what I mean, it's almost cantilevered. So what's gonna happen is the water's gonna flow and fall off of the rock, and that's gonna give us that effect that we're looking for. Now this side, on the other hand, has the broken fractured edge, but the face of it is not negative, it's actually bulbous, it's actually proud, it's sticking out past that broken edge. So the water is actually just gonna kind of hug this edge, and it's not gonna be the desired effect. I don't wanna draw a lot of attention to this piece. The other thing that I'm thinking of is how it's interacting around the other rocks. So I placed this rock next to this one because it looked like a hollowed out cavity. So I want to accentuate that. So what I'm going to do is I'm going to take a few more pieces of rock and I'm going to create like a little bit of a broken fractured pocket here. So the water's going to fall here and then it's going to fall again. So it's going to split that height in half. So instead of having one even waterfall, the exact same elevation all the way across, we're gonna have a tall one here and we're gonna split it in half on that side. It's gonna change the sound, it's gonna change the look, and that's what it all comes down to, is changing the sound and the look. So we're always taking into consideration the main viewing areas. You don't wanna overwhelm the space with too much sound because it actually could get annoying. So we just wanna have that subtle background noise that we all crave and love.
Hey, Dave Kelly here, VP of Product Development. So we're taking advantage of this nice cold 40-degree weather to test out some foam. Our foam and some other brands out there that also make foam. It's 40 degrees, so this is about the extreme you're going to get when you're testing foam out. As you can see, this is our foam right here. It's got kind of a spongy feel to it, kind of a rubbery feel. Here's another one right here. A little lighter in color, but also has kind of a rubbery feel to it. Here's a third, brand C, call it. Turns into dust. Now in the summertime, warmer weather, they may all three react the same way, but in a more extreme temperature like this, these are the different consistencies you get with foam.
This one's perfect.
I'm always using biomimicry techniques to use nature as our model. So what I wanted to do, instead of just having this one waterfall coming down, if you remember, I placed this one small rock. It seems super insignificant, but what it does is it redirects the water exactly like what you would see in nature. If you look across, we have this big hollowed out section over here as the water would scour its way into the earth. So I wanted to make the force of water go in that direction. What it does is it creates a backwater area over here. You can see there's literally no turbulence. There's leaf debris and everything accumulating in that section. That's where sediments are going to accumulate. Wherever sediments are, that's the source of life. That's nutrients. That's going to feed aquatic vegetation. This is going to be a perfect spot from the main viewing area to have a small pocket of aquatic plants, exactly where they'd be found in nature. And again, it's those subtle little things that make all the difference in the world on every one of our projects. It's always a good moment when we get the water flowing, and it looks phenomenal. This is not a massive waterfall, but it still captivates. It still grabs everybody's attention from all different angles, which is always what we're thinking about. We want to pick up all the different viewpoints, and we want to create that subtle, beautiful sound of that cascading water.